Hello guys, now I'm going to do this second part for the section 12.3 for your SM1 class. I'm going to do two exercises from the book. They're pretty short, but hopefully they will help you understand how we use the SAS Congruence Theorem in different situations, okay? So let's get to it. I'm going to start with exercise number 10 from page 605 from the book. And the question in each of these exercises is if the two triangles are congruent by using the SAS Congruence theorem. So let's begin analyzing exercise number 10. This exercise is showing you a couple of triangles, triangle LMN and triangle NQP. And the statement is that triangle LMN is congruent to triangle NQP. Now we have to show using the SAS Congruence Theorem if that is true. So let's begin. I'm going to start analyzing what the diagram is showing me. The diagram or the figure shows me that the segment LM has a corresponding segment, in this case on the other triangle, that is NQ. And at the same time, apart from being corresponding, it means they are located on the same side of the triangle. They are also congruent because of this double mark, which is good because that is some kind of the beginning of my statement, because I am making sure that there is one segment that is congruent on the triangles. Now let's continue with the angle. This angle right here is a right angle, and it's telling me that its corresponding angle is angle Q right here. They are corresponding and they are congruent. Okay, so I have an angle that happens to be congruent in both triangles. Now, the final part of this is the segment MN and segment QP are corresponding and also congruent because of this mark, as you can see. So, the last thing I need to verify is if the angle that makes this theorem true is being formed by those two segments. And as you can see here, this segment and this segment, LM and MN, form angle M. At the same time, the segment NQ and segment QP form angle Q, and they are corresponding. In this case, I just verified that this happens to be true. Okay, so I just proved that. This is a kind of informal way of verifying that this is true. So yes, this is true. Now let's take a look at number 13. Number 13 is showing you a couple of triangles. The triangles are EFH, EFH, and triangle GHF. This one, GHF. Are they congruent is the question using the SAS Congruence Theorem. So let's take a look. We are going to follow the same reasoning here. And as you can notice, and I'm going to do some things that if you want to explore a little bit further, you will need to check the video 12.2 annex. It's already here in the channel, guys. So let's take a look at this. In this case, I need to make sure of something. Probably the best way is if I can imagine doing that, or I can try to do this. I'm going to grab this triangle and I'm going to switch or tilt it so that it gets to this form. If I take this, so now H is going to be turned to try to have the same orientation of this triangle, so that I have this, and see if they happen to be the same. So when I do this, I will do G be here. Okay. Now, in this case, when I did that, this is going to be H right here, and F is going to be right here. Okay. With that in mind, now I can take also this thing. GH is now right here. Okay. It coincides. And this angle that happens to be congruent to this other angle F is right here. So now, as you can see, they have the same orientation that it helps you see this thing better. FH is right here and FH is right here. So can you see that this segment is the same as this segment? So in this case, when I separate it, I could say that this is the same as this. And here's the thing. If I want to use SAS, and if you take a look at this triangle and this triangle, you can notice something. You can notice that even though you have two congruent segments and one congruent angle, this triangle EFH is showing you that the angle that is congruent on the other triangle is in between the segments. But in the other triangle, the angle is not in between them. So it means that the congruent triangles are not corresponding. So in this case, SAS is not being satisfied. So in this case, I could say that these two triangles are not congruent, okay? And that's what concludes these exercises and this session. Thank you very much.